This is a warm-up lecture for our online JavaScript course. We'll talk a little about the nature of JavaScript, which we'll refer to as JS from now on. And we'll show a bit of interactive JS just to get familiar with it, and we'll talk about the course content. So, preliminary reading first up here. You should already have read the course guide and followed it, the instructions in it up to the point of having a JS interpreter or a script application accessible and running. If you haven't done this yet, please pause the lecture and do those steps. We'll be trying out some JS code shortly, and you should be ready to try it out along with the lecture. Also, before you proceed further, please read the first portion of the Reintroduction to JavaScript from our bibliography at the MDN website. Stop at custom objects. You should not bother to read that yet, but everything before that. In this lecture and some others, there will be preliminary outside reading expected, and in-lecture questions at the start of the lecture regarding that reading. When concepts are straightforward and they're explained well by existing documentation, we won't spend lecture time reiterating them. So, on the assumption you just did those two things, let's look a little bit at JS from a high level. But first, the promised in-lecture questions, and a chance to get used to this in-lecture question drill if it's new to you. So, relating to the preliminary readings, question 1. What's the relationship between Java and JavaScript? And the way these always work is I'll ask you to pause the lecture, think for a moment if you need to, come up with an answer, and then resume the lecture, and you can either hear the answer or, of course, read it in the transcript, which you'll find is always in a small font because that makes it possible to read, but also possible to ignore while you're still thinking about it. And you can choose to read it when you like. So, answering that first question after a pause, virtually nothing is related between them. They have virtually no relationship between them, aside from their names and some similarity in syntax. JavaScript has C-like syntax, as does Java, but it was originally called LiveScript. The JavaScript name was a marketing suit decision to raise JS's profile in the mid-90s when Java was a hot buzzword. So, question 2. Who invented JS, and where did he or she work? And again, coming back from a pause, if you need to remember, the name is Brendan Eich, and he worked at Netscape, and still works at Mozilla today. So, question 3. What are the standard input and output functions or statements in JS? How do you read and write as part of the JS standard? Coming back from a pause there, the answer is there are none standardized. Or more precisely, there are many, and the particulars of I/O vary depending on where JS is being used. Any implementation of JS includes some built-in global, not part of any class, functions and global objects for dealing with the outside world. If the JS implementation is in a web browser, which is by far the most common case, then there will be built-in objects and functions for working on the HTML layout of the current web page and for communicating back to the related web server. If by contrast JS is in a standalone interpreter, such as the JS script or JSDB apps that the course guide recommended you install, then there'll be a handful of functions for reading from the keyboard and writing to screen. Usually these are pretty rudimentary, because JS is principally designed for embedding in browsers. But we'll use text.io for starters in order to look at the language without the distraction of all the browser topics like DOMs and CSS and HTML. Now, if you were not able to answer at least 2, and preferably 3, of these in-lecture questions without looking at the answers or returning to the reading, then take it as an indication that you need to do preliminary reading more carefully in the future. The in-lecture questions in general are your free, no-pressure benchmark on whether you're reading and listening well enough. And they're also a chance to think carefully about the concepts. And they'll often take much more thought than the simple questions just asked. Take the time to reason the hard ones through, even if it's 10 or 20 minutes. Trying to figure ideas out for yourself is the most powerful way to learn them. They stick better in your mind, and you gain confidence. So let's head into our first topic related to JS itself. The readings don't emphasize this much, but JS is interpreted, meaning there's no compile step. Browsers or applications that run JS read the source code directly, parsing it on the fly as an integral part of execution. This is a bit of a waste of time since a JS program is in effect compiled each time it's run, a waste of computer time we should say. But it makes rapid incremental development a joy. You simply save each modified version of your code and then run it immediately. No build, compilation, makefiles, etc. And in a JS shell, you can try out JS statements by just typing them directly and running them, which is great for experimenting with the language. We'll do a good bit of that in the upcoming lectures to illustrate various concepts. Sometimes the lecture will focus on a full JS program, but other times the working example will simply be a conversation with the JS interpreter. For instance, let's do some JS statements now. I'm going to fire up my JSDB interpreter here, and you should do the same for your JS interpreter. So let's start by declaring a JS variable, which you do with a var keyword and then x. And then we'll put a value into it. As you can see, this assigns 42 into x, but it also prints 42 right there. When you run JS in interactive mode like this, the shell prints the value of any expression you type. You should recall from your Java or C experience that assignments are expressions. They have a value, as well as copying something into the left-hand target. That value is simply whatever was assigned, and thus this explains the print of 42. It's the value of the assignment expression we just wrote. We can use the same principle to show the content of x. That's a very small expression, which, as you see from the output, has the value 42. So the assignment worked. Printing a variable's value by simply stating it as an expression only works in interpreted mode. In code, we'd use the print function thus. This prints its argument, but without a return at the end, as you can see, unfortunately. We'll add the return in a later lecture segment. Let's just live with that ugliness for now. Now, here's question 4 for you. On what page of the ECMAScript standard is this print function described in detail? Now, don't go racing off to read the ECMA standard. Only its authors think it's readable. This is a trick question of sorts. And by the way, if you're wondering if ECMAScript is some kind of acne treatment, do the preliminary reading more carefully. So, coming back from a pause there, if you've been thinking about it, as the preliminary reading indicated, the ECMAScript standard, technically standard ECMA 262, which sounds even more like an acne treatment, is the formal JS standard written by the European ECMA Standards Organization. And print is mentioned nowhere in it because it's not part of the standard. Remember that I/O varies per JS implementation, and each JS shell may have its own subtly different version. For instance, in the JS script shell, print adds a return, but not in the JSDB shell, which I'm using here, unfortunately. The ECMA standard forms the basis of a number of closely related languages, by the way, including JavaScript, and ActionScript, which, unlike Java, really are just JS variants, very closely related. That's question 5. Let's try one more interactive expression. We'll type up here 0 divided by 0. And it says Nan. Why? Who's Nan, and why is her name camel-cased? Again, coming back from a pause there, if you had no idea what Nan is, do the preliminary reading carefully. I'll stop harping on this now. I imagine you have the point. As the prelim reading indicates, Nan stands for not a number, and it's the result of putatively numerical expressions that cannot be resolved to a numerical value. The reading doesn't explicitly offer 0 divided by 0 as an example, but it makes sense that this would be Nan. It's indeterminate. It's not even infinity. which, by the way, is what you'd get for 42 divided by 0. Let's try that. Yeah, infinity. Now, another point about JS. JS is loved and hated. You can catch a bit of this in the tone of the preliminary reading. As you'll discover repeatedly as we get into JS details, JS is a pretty amateur language design. It's full of dumb behaviors and odd missing pieces. But at the same time, it includes some powerful and beautiful features like prototypal inheritance and closures. We'll get to these in detail later. So JS programmers have a love-hate relationship with the language. Sometimes it seems like some practical joke by Ike that escaped from its creator. Oh my God, you mean you put it in the browser? I was just kidding. Other times it's the language of the future, or at least has the features of the language of the future. And then, despite its weaknesses, it's useful to understand that JavaScript is as ubiquitous as cockroaches. It's one of the most popular languages in common use, trailing only Java and perhaps C as of this writing. Every web browser includes it, and it is the principal language for any web application that runs in the browser. Given JS's acceptance as the standard language for client-side web apps, the cockroach simile is doubly appropriate. JS is probably unkillable, even by hard radiation, and it will be in use for decades to come. So it's worth the investment to know it well. So what are we going to do in the class? Well, we'll start right off with a small, by which I mean around 200 lines, JavaScript program that shows many of the basic language features. And that will take several lectures as we go line by line through it. Then we'll look at more detail at the concepts introduced by that initial example, including JS objects, elemental types, and arithmetic, objects or constructors, the nature of dynamic objects, JSON, prototypes. We'll touch briefly on Closure as well, and do a couple of exercises with it, but Closure and the myriad rich design possibilities it opens are left for the more advanced JavaScript course that follows this one. And then, to set a pattern that we'll use in lectures to come, here's a brief external research question for you. Check the docs, the MDN materials are a good start, and answer this question. How do I compute a square root in JS? Write an expression in your JS shell that results in the square root of 42. And coming back from a perhaps lengthier pause there while you did that read. Math.square root 42. Looks a little like Java, doesn't it? The math object, JS has no classes, as we'll see, so that's an object, includes the function square root. It's a lot like the math class in Java. And hopefully this question also got you to browse the JS reference and similar material at the MDN site so you know where to look for similar answers.